Hello, good morning, good afternoon, and good evening, wherever you are. Welcome to LGTF on Cloud Native TV. Hello and welcome. You know what? I'm going to deviate from my script a little bit. That video was awesome. I really like that.
The
I need to
intro,
reach
yeah,
out. I need to
it
reach
took
out
me
to
by
Paul
surprise.
and ask who did that. That's great. Anyway, sorry, professional me. Welcome to LGTM. This is Cloud Native TV. This is a show where we will focus on showing you how you can contribute to Cloud Native projects. Today, we're taking a look at Linkerd from Buoyant, and I am fortunate enough to be joined by Matej David from the Buoyant team, who is also a Linkerd maintainer. Before we speak to Matej, I just want to remind you all that this is a CNCF event, and as such, there is a code of. I'm on form today. There is a code of conduct in place, so please be respectful to everyone in the chat and to us on the screen. All right, hey Matej, how are you today?
Yeah, hello. I am fine. A bit nervous to be here, but I'm also glad to finally be able to show people a bit more about Linkerd. We're always excited about new contributors, and yeah, we're excited about new adopters as well. So, hello everyone, and yeah, glad to be here.
Well, there is no need to be nervous. We are only 2 minutes in, and I have already made 3 mistakes, so you are golden. Can you do us a favor and just let's just tell us who you are, what you do, and we'll take it from there.
What's Mate all about? So, yeah, I'm a software engineer. My name is Mate. I work at Buoyant, as you can see from my branded hoodie.
A nice hoodie.
Yeah, I know. I actually love it. It's one of my favorites at the moment. But yeah, I'm a software engineer at Buoyant, and I'm working full time on Linkerd. So I'm fortunate enough to work full time in open source. I graduated university 1 year ago. I've been working at Buoyant for about 4 months. I think time flies by pretty fast now. But about 4 months. But I've been a Linkerd contributor for well over a year now. I started as a student, and yeah, now I'm doing it full time, which is awesome.
I think that's really fascinating. This is a bit different from previous LGTMs in that I think so far we've always had co-founders and maintainers of projects, whereas your story is a little bit different. Like you said, you were studying at university, you became a contributor, you've worked your way through to maintainer, and now an employee at Buoyant. Do you want to share that story with us?
Yeah, and actually, I love sharing the story because to me, it kind of brings out that perseverance is key. And, working hard does get you places. And I think it also attests to how inclusive the Linkerd community is because they've all been super welcoming. They've been very supportive for my entire time there. But yeah, I started out as a student. I knew about Linkerd from a previous internship, but I didn't really know what it does. I knew about service meshes in general, but, I knew about the term, but hopefully we'll get to demystify it a bit. But it was still a bit confusing to me. And at the time, I was actually looking for a summer internship, and I was thinking of breaking into open source. I had a couple of contributions before then, but it was nothing major. And I sort of by mistake found Linkerd. I kind of associated it with the Linkerd that I heard of, and I was like, well, this might be cool to work on. It's in Go. I don't have to learn a new language, so I might as well. And I was looking for issues to contribute to, and everything seemed super scary. So it actually took me about 2 weeks of overthinking before I, just went straight in for it. But yeah, I had my first contribution. I had a blast. Everyone was super welcoming, like I said previously. And then I decided, you know what? I actually had a lot of fun. I got a lot of great feedback. Why don't I try to get an internship with them over the summer? Because that would be ideal. I can work from home. The pandemic wasn't a thing back then, so in my mind, I could have worked from home, could have had my holiday and everything in between. So I actually applied for an internship sponsored by Google. They have kind of like this summer of code thing where they sponsor people to work on open source. But my initial proposal was rejected. And I didn't put a lot of effort into it, come to think of it now. I think I was also limited on time. Not to say that I didn't put a lot of effort, but I think it's not the kind of proposal that I would have been extremely proud of. So I was rejected the first time around. And I said, you know what? I don't care if I'm rejected. I still want to work with these people because I started to like the project. By this time, I already had my second contribution, attended a community meeting, so on and so forth. So, I don't want to tell you my entire life story, but long story short, I submitted another proposal to a program ran by CNCF, which is called LFX Mentorship. Got accepted, got paired up with a mentor from the Linkerd team, and I worked on Linkerd over the summer as an intern. And since the summer, I entered the industry after university. I worked for a different company, but I kept contributing to Linkerd, and I've been a big advocate of the project so far. And after a while, I liked the team liked me, so we said, let's just work something out. And now I'm here.
Awesome. That's a really great story. Do you mind if I ask a few questions?
Yeah, go ahead.
Awesome. Do you remember what your first contribution was?
Yeah, it was an uninstall command for the CLI, which is why I was so confused about everything, because I saw all of these issues that people picked up and they seemed relatively easy. And then the only one that was available was this uninstall command. And I was like, damn, like, what am I going to do? I don't even know how this stuff works. So
nice. And I'm curious about your programming experience prior to that. I'm assuming your contribution was in the Go CLI, right? Had you written Go before?
Yes, I did write Go before at my previous workplace. I had an internship, like I said. I didn't know a lot of Go at the time, but I did have experience with it before. But before I started contributing to Linkerd, I would have labeled myself as a Java developer, if you can actually.
Wow.
Yeah, I know. I'm surprised too, but that's how it is. You grow up and you cringe at yourself.
Well, I think we've all written Java at one point in our life. And I've got to say, well, I think the JVM has had problems in containers. What they're doing recently with the JVM, I find really interesting. But that is not a session for today. Okay, so let's end. I mean, really cool story. And I think, I'm going to introduce you to Pop. I think it would be great to do that student journey. But can you just maybe give, and this is unscripted, I'm sorry if I'm putting you on the spot, but do you have any advice for people that were in that position, that are students that are looking to do internships or want to contribute to open source?
Well, I do have a couple of pieces of advice, let's say. And I know they can be cliches, but all of them revolve around communication and interest. If you're interested in something, you have to understand that open source communities in general are very welcoming, especially the CNCF as a whole. The CNCF landscape is very welcoming. I think if you'd like to be a contributor in this space, you've definitely made the right decision, because all of the interactions that I've had so far were great. So yeah, I know it's going to sound a bit like a cliche, but my advice is communicate, get involved in, the communication channels that the project you want to get involved with has. Say hello to people and always ask for help. I think that's been one of my keys to success. I've been asking for help whenever I'm blocked. I let my team know, and I'm not embarrassed to fail. I think failing is very normal. I think we should normalize it, especially for students. You don't have any prior experience. You come in, you dedicate your time for free, and yeah, don't be afraid to fail. Just, go straight in and do your thing. That's my advice.
You know what? I couldn't agree more. In fact, I'm sure people are fed up with me saying this, but I always say my superpower is that I don't mind asking stupid questions or looking silly. Like, it's all in the name of experience and learning, and that's what helps us grow and become better in this industry. It's only through failure that we really do adapt and learn. So yeah, fantastic advice. Okay. Do you want to pop your screen up? We do have a question, which is probably quite pertinent to right now, so we'll tackle that as well. But if you want to get, I know you're going to start off on the Linkerd website, so let's do that.
Yeah, just give me a second.
Go for it.
Oops. All right, cool.
Let's see.
So we're on the Linkerd website now.
So you ready for your first question before we dive in?
Yeah. Let's get the first question.
All right. So Import Human says, hello, looking to contribute to Linkerd, but I'm unclear about service meshes, sidecars, and connected services. Can you please provide a low-level introduction? So I think that ties in perfectly with what we were going to start with there.
It does, because that's the starting point that I had in mind. So one of the things, like I previously said, when I heard about Linkerd, was that it's a service mesh, and I was a bit confused as to what the term implies. So first of all, hello, welcome to the stream. And second of all, to answer your question, a service mesh is what we call a tool that you kind of use at a platform level. So in a Kubernetes cluster, you usually have a lot of services that are running. There are usually microservices or distributed systems. This is not necessarily about that, but a service mesh helps you achieve a couple of things at that platform level. So you can get security, observability, and that kind of stuff at a platform level rather than doing it at an application level. And the second part about your question with sidecars and the way that services connect to each other and talk to each other, that's kind of an implementation detail about service meshes, because with Linkerd 1, for example, it wasn't working with a sidecar pattern. And by the way, we're talking about Linkerd 2 today. We also have a Linkerd 1 version written on the JVM, speaking about Java developers. But those sidecar patterns are a way to run your service mesh. And why don't I just actually go to the docs? So we're on the Linkerd website now, and I'm still going to answer your question, don't worry. But I just want to go to this reference page because we have an architecture diagram, and I think it's going to help exemplify everything a bit better. So the way Linkerd works as a service mesh is that it's split into two parts. It has a control plane and a data plane, and you can see this over here. The control plane are a set of components that we use to make some informed decisions. For example, we have a destination service that we use to kind of resolve destination targets. And don't worry, I'm going to get to that part in a second. We have an identity component to manage certificates and stuff like that. The real magic in a service mesh, and certainly in Linkerd's case, comes from the data plane. So we have what's called a proxy that you can kind of inject next to your container. So in Kubernetes, a pod can have any number of containers. It's not restricted to just one container where your application runs. So a sidecar pattern essentially means we add another container with this proxy in that will be responsible for handling all of your network calls. So if before your application would talk directly to a service, now the proxy will pick up that network communication and forward it on your behalf. And this allows us to do a bunch of stuff, such as encrypting your calls, because now your connection goes in the same container. In the same pod, it goes to a different container. So it goes directly to Linkerd. It's pretty secure. And then from that point on, Linkerd encrypts it and forwards it encrypted to the destination, where it does the reverse. It unencrypts it and sends it to the application. It also allows you to pull metrics, because now you can kind of have that control over the networking calls. And a bunch of stuff around it, such as load balancing and other nice things like that. And for load balancing and all of the added functionality, we use the control plane, like I said before. So, you want to talk to a service, the proxy first looks at the network request, and it's like, okay, well, where do we need to go? We need to go to service B. Do we know anything about service B's endpoints? So it goes to the destination service, fetches all of that data, and then makes an informed decision. So I don't know if it's a complicated view on things. David, let me know if I should simplify it a bit. But in a nutshell, that's kind of what it means. We take over your network connections, we forward them for you, and in the process, we make everything better. We give you observability, reliability, and security.
I think that one-liner is great there. Just, we take over your traffic and make everything better. Job done. That's the service mesh.
10-second elevator pitch.
Import Human is in the chat saying thanks. That helps a lot. So there you go. Perfect.
Cool.
All right. So and Jason Morgan's in the chat as well. Sounds like a pretty good explanation to me. There. Everyone's happy. Do you want to jump into the GitHub page and let's take a look at the Linkerd repository?
Yes, for sure. So let's take a look at the org first of all. So we have a couple of repositories here.
Could you use a few clicks on the Zoom?
Yes, of course. I forgot the Zoom Chrome. let's see.
Perfect. Thank you.
Cool. So this is the Linkerd organization. You can find us on github.com/Linkerd. And in here, we have a couple of repositories that we use. The most three important ones for new contributors, I think, are the ones at the top, coincidentally. The website, where we usually have documentation updates. So most of our documentation is hosted on the website. That's why I wanted to start with the website. And we absolutely love documentation contributions. And I can't actually stress that enough. If you are a new starter, doesn't matter if you're a contributor or an adopter, and something is not clear, or you want to add something to the documentation, definitely get an issue in and a PR. We love that. We'll really appreciate you. And then we have these two repositories, Linkerd2 and Linkerd2 proxy, which is written in Rust. So Linkerd2 is where we do all of the issue triaging and where the control plane code lives. So yeah, as you can see, we have a common Go package structure. I'm going to go through all of these shortly, but yeah, you're greeted with the README. We have a complete list of all of the repos that we manage. Quick start and documentation. This is a great place if you're just getting started with Linkerd. Just click on this and we'll get you set up with running with an example. And yeah, where should we go from here, David? Should we go to any of the docs, or do you want to talk about the code itself?
So what are the major components then of Linkerd?
Yeah, good. Glad that you asked that. It's a very good question. So everything, all of the major components are going to be in this kind of controller directory. But before that, I want to say that prior to the version that we're running now, Linkerd 2.10, we used to have let's say, a more full control plane. That doesn't sound correct, but our control plane was made up of more components. So it included the observability stack, such as Prometheus and Grafana, the destination service that I mentioned earlier, and so on. But we actually moved to an extension format now, where we kind of eliminated everything out of the control plane that is not necessarily important to get Linkerd up and running, so that the control plane is just a bit lighter and users can opt in into what functionality they need. So I said that because we have a couple of components here that don't have anything to do with the core installation. So one example is the Viz extension. Everything related to our observability stack, such as our Prometheus instance and Grafana and the metrics API, so you can see everything in the dashboard, lives in this Viz extension. We also do multi-cluster as part of Linkerd. This lives in its own extension directory here. We also have a Jaeger extension, and you kind of get the point. There are a couple of directories here that have to do specifically with extensions. But then for the core control plane, we actually don't have a lot of stuff in at the moment. So what we're left with is a proxy injector. This is what we use to inject proxies as a sidecar into your application. So when you install Linkerd, you install the control plane, and everything is nice. Linkerd can function properly. But when you want to add it to your application, we need to inject the sidecar. That's what we call it. And you can do this on your own, but it's generally kind of a lot of YAML files to write. And the less YAML we write, I think the better we are off. So we provide automatic injection. You put an annotation on your Kubernetes object, and you say, okay, I want this to be injected with the Linkerd data plane, and the proxy injector will do that for you. And for those that are interested, under the hood, it's a Kubernetes mutating webhook. So it's a webhook server, and it ties in with the Kubernetes webhooks system. Then we have an identity component. The identity component is used to issue certificates to the proxies. So the way we install Linkerd usually is we have two certificates. We have a root trust certificate that should ideally, not change very often. And then we have an issuer certificate that's used to sign other certificates. And, the whole PKI kind of aspect of it is a bit confusing. But what you need to know is that every proxy will get its own certificate every 24 hours, and it will use the certificate to encrypt your connections, to have MTLS. And the identity service is responsible for scoping those certificates to be 24 hours and when they expire to reissue them. So yeah, that's
Nice.
the second part. And finally, probably the component that I worked with most, it's the destination service. So you can actually see me, I'm the last one who committed code here. The destination service is how we kind of manage service discovery in Kubernetes. So I previously said that, we do some service discovery up to a certain point, so we can do load balancing and, provide retries and timeouts and all of that stuff. So everything related to that is in this destination component. And that's it.
Awesome. So that was, I think that's a pretty good overview of the repository. Now, putting my new contributor hat on, they want, they're told, like, you've described service mesh, they've went, that sounds cool. Okay, I understand the layout of the code and where the components are. Like, what is the best way for them to find an issue to get involved with the project?
Right. So again, glad you asked that. We have issues here. So we do most of our communication on GitHub. Everything. So even us, the maintainers, we generally try to be very transparent with what we're working on. So every single issue that we can think of is filed here, and we tend to have discussions in the actual issues themselves. So as you can see, we currently have a couple of things in the backlog. I'd usually break down issues in the backlog in three categories based on. So this is based on what I've observed so far by working on it. But we have issues where Linkerd is not working properly. For example, here, you drain a single node and a reboot causes failure. So in this case, something is going on with Linkerd. Same with this one. Those are usually things that we want to reproduce and we want to investigate. So is Linkerd actually misbehaving in this case? Can we do anything to get around it? Is there any configuration that we have to apply? Then we have feature requests and bug fixes. And those are usually labeled with help wanted. Not all of the time, but we try to label them as much as we can. So just because you said you put your new contributor hat on, I want to dive into the labels that are very applicable for new contributors. So usually it's a good idea to filter everything by labels because it makes everything just a bit easier to see. But we have different areas depending on which component that you want to work with. I usually suggest that new contributors start either with CLI or with tests because these require generally the least context. So it's much easier to hack something together. And then we also have labels for new contributors specifically. So we have good first issue, which if we apply, we'll see we have a couple of good first issues here. I think some of them are currently taken, but yeah, if you're curious about contributing, definitely have a look for these. And we also have help wanted. So help wanted is generally a label that we put so we can advertise an issue to external contributors and be like, okay, if you want to work on this, feel free to just take it, just work on it. It doesn't necessarily mean that it's a good first issue, but it can be. It usually means that it has a bit more context to it. So if you take a help wanted issue that's also not a good first issue, you just might have to do a bit more research. But we generally keep it very simple. You have this good first issue and help wanted. But if you're an external contributor, it's not a requirement for the issue to have the help wanted label on it. So if you just find something in the backlog that you think sounds cool and you'd like to work on it, generally, open the issue up, look at the comments. If there's nobody working on it, just write a comment. Hey, I want to work on this. Is this cool? And 9 times out of 10 it is.
Okay, perfect. So now that I know my way around the code, I've found an issue that I would love to try and contribute to the project. I'm going to have to clone this down, and maybe you could guide us through the build process. I guess my first question is, do I need a JVM to build this?
No, thankfully, you do not need a JVM. So when you're a new contributor, what we generally tend to recommend is you fork the repository. So you have this button here, fork, you click it. Well, I'm already forked, so I can't actually do it to show you, but you fork the repository. This is going to create your own repository clone that you can kind of play with. You can commit to main, you can commit, anywhere you want, and it's not going to impact anything. Once you have that, you usually just have to clone it. And I'm just going to switch over to my terminal just to go through all of the build things and show you how to get Linkerd up and running in a cluster.
Yeah, go for it.
So just let me find the window. So right now I'm in this lgtm directory, but I'm going to go to Linkerd. So normally, I said you fork the repository and everything, and then you just git clone. This is actually a fork from somebody's PR that I reviewed. So you clone it, you go into the repository, and from there you read it with all of the Go files. Now, getting started is actually quite easy because simplicity is kind of key with everything that we do with Linkerd. So we don't like configuration, we don't like huge build processes. We really want to keep everything simple. So to do that, we actually have a couple of scripts that we have available. One thing that I want to note before I go any further is that with Linkerd, you generally need a Kubernetes environment. And seeing it in action is also a bit difficult because you need an application that can send traffic, right? Because it's a service mesh. You want to see how it handles all of the metrics, how it handles traffic, so on and so forth. But don't worry, we got your back covered. What we tend to do, because we're an open source project, we tend to do all of the environments locally. And we use K3D for that, or Kind. Those are two projects that are really cool. They allow you to run Kubernetes in Docker containers on your machine. So that's what I'm using. I'm using K3D. If you're using Minikube or anything else, that's also fine. It's not really a requirement, but it's definitely helpful. And I think in bin we have a K3D script. So if you don't want to download the K3D binary, you can also just use this script straight away to create a cluster. So I'm just going to create a cluster demo right now. And this hopefully will not take long. And while this is underway, I'm just going to go over to this getting started page on the website, because generally if you're a contributor, if you're a new contributor or an adopter, this is the page that I always suggest that you follow. And you can take my word for it. I've done a lot of Slack support, so it's really, really helpful to go through this getting started guide, because it kind of helps you get Linkerd up and running. And it might explain a few things in more detail than I'm explaining. But this is the step that I wanted to highlight. We want to install the CLI. So with Linkerd, we allow you to install Linkerd either through Helm or through the CLI. I'm a CLI kind of person, so I'm just going to use this. I already have it installed, so this won't actually do much. But essentially, it's just a script that downloads the Linkerd binary and just installs it. So if we do Linkerd version, we'll see that we have this client version, but we don't have a server version because it's unavailable. So the next step is to actually get Linkerd deployed onto your cluster to kind of have a look at everything. And that's actually kind of easy to do. All you have to do is say Linkerd install. I'm not going to apply it yet because I just want to show you how it looks like. And what we do is we just render some manifests for you for the control plane. These are all deployments, services, service accounts, so on and so forth. It's nothing special. It just renders everything. So normally what we do is once we install, we pipe this to kubectl and we say just apply all of these manifests and create the cluster. Create the Linkerd control plane. Now, I actually already have a cluster with Linkerd up and running, just so I can save time. And if we have a look at the namespaces, I have also installed the Viz extension. And just to show you how easy it is to install that too, you just do Linkerd viz install, and then you apply it. It's kind of the same principle as the main control plane. Let's see, did I miss anything so far? So we can get the namespace. Oh, and now if we do Linkerd version, we'll see that the server version and the client versions match. Now, once you're done with your changes and you want to test that everything works, we also have a bunch of scripts to do integration tests, to build the binaries and everything you can think of. We have a build.md file where we go into depth when it comes to this, and kind of show you what the repo layout is, how you can build each single component, and so on. But what I usually tend to do is just execute the script. Bin docker build. This will this will build all of the Docker images, and tag them with the current Git version. So just to show you an example, this will, for example, build a proxy, and it will just add this Git kind of hash to it as a version. Once you're done with that, you generally want to use this script, image load. We support K3D and kind, and this will basically load the current images into your cluster. So I realize this might not make a lot of sense now, but I already prepared an issue for us to work on. So maybe if we go through that one, we can see at the end exactly how everything works out in practice.
That sounds great. Yeah, let's do it.
Cool. So I am, again, over here in the repository. And I already picked up an issue yesterday. This already had the help wanted tag, so it happens that if I wouldn't have picked it, you could have worked on this. But I guess, I'm going to do it now. Cool. So what I want to do here is kind of not just work on the issue, but explain my thought process and how I usually approach these kind of things. And again, going back to my experience when I first started, I saw the issue. It had all of that text. I didn't have the context, and I was like, well, now I just need to learn everything there is to know about service meshes. But that's not actually necessary in a lot of the cases. You need a tiny bit of context so you can get the job done, and it's usually enough to just read whatever the issue says and just dive in straight into the code, and everything will make sense. I promise you. But in this case, Jason, who is actually watching the stream now, hello Jason, he raised a feature request, and the feature request is pretty simple. I'd like to see Linkerd metrics for replica sets. So at the moment in the UI, Linkerd doesn't report metrics for replica sets, and there's a reason for it. We generally only report metrics for the root object of a pod, and that sounds a bit complicated, so let me rewind. When you deploy your pods into a Kubernetes cluster and you inject Linkerd with it, Linkerd will start reporting metrics for these pods, and you'll be able to see them in the UI. So actually, why don't I just show you how that looks right now? It's always much easier to exemplify everything. So this is the dashboard that comes with the Viz extension. Once you install the observability stack, you're going to see everything. I'm just going to zoom in so it's a bit more clear. Let me know if this is okay, David.
Yeah, it looks good.
So over here, I have an example application installed called Emoji Photo, and it's just a series of deployments that all communicate to each other. And if we look, we first have this topology graph where we see exactly how components talk to each other. And then we also get some metrics for the deployments themselves. We get a success rate, requests per second, so on and so forth. And then we also get metrics for the pods themselves. If we scroll over to replica sets, we don't have any metrics. And this is fine because replica sets in Kubernetes are usually managed by the deployment. So there's no reason to report metrics in two places for replica sets and deployments. Just report them for deployments. It's the authority in this case. It's the topmost object. So to go back to the issue, again, the problem is that we'd like to see Linkerd metrics for replica sets. And an obvious question now is why? Why do we want to do this? And it turns out it's because it's linked to another issue about Argo rollout deployments being invisible. And what Jason says here is that when we have an Argo rollout, we can't actually get any metrics from it because we don't handle that object type. It's invisible. And that's true because Argo rollouts. So I'm not awfully familiar with Argo rollouts, by the way. I literally Googled it for 15 minutes yesterday when I first saw the issue. And all we need to know about it is that an Argo rollout replaces a deployment. That's it. And because it replaces a deployment, Linkerd kind of gets a reference to this rollout object type, and it doesn't know how to handle it. It's kind of scratching its head, well, what do I do with it? And because it doesn't know what to do with it, it just drops the metrics completely. And this is what Jason is saying. Hey, let's add in metrics for replica sets so that when we do have an object type that we do not recognize, we can just get metrics directly for that replica set, so we at least have something in. And then the next step that I do after I understand the problem is go through the conversation, because usually the most recent comments give you the most context in this case. So we can see that Alejandro, one of my colleagues and Linkerd maintainer, really pinpoints the problem to being in this specific function. And he says when we inject the pod, and we talked a bit about pod injection and how it adds those proxies to it. If the parent of that pod is a replica set, and that replica set's parent is also fetched, it's returned as the pod owner. When it's a rollout, we don't recognize it, so we don't have a parent. So then the problem here becomes quite simple. In specific cases, we want to return the replica set parent. In other cases, we want to return the replica set itself when its parent is not valid, such as when it is a rollout. And then we have another comment from Oliver, creator of Linkerd. And he says the correct solution is to make everything more generic, but an interim fix is to just fall back to replica sets when a deployment cannot be discovered. So hopefully, if you've stuck with me so far, this all essentially means that we need to change the code so that when a replica set parent is invalid, we just return the replica set itself. And this is all handled in the skip owner kind of name function. So we don't have to do much. We'll just look at where this file lives. It's in controller k8's api.go. So I think we're pretty ready to dive in.
Yeah, I've got to say, when you first pulled up this issue, I was like, crap, how are we going to fix that in the time that we have? But, just by, going through the conversation and talking about what the problem space is, like, I think by like the third or fourth comment, when you got down to Oliver's, I was like, oh, like this is probably a 2-line change. And that all came from your narrative and those comments and conversation.
Exactly. And that's what I wanted to really bring out. It's just necessary to look at the issue, kind of isolate the context for that issue. And, most of the times it's going to be fine. Of course, there are exceptions to this, but usually when you're a new contributor, you're not going to dive into, the most complex proxy changes either. So cool. But the next thing that I usually do when I have one of these examples, one of these issues to work on, is exemplify it. I first want to see how everything behaves normally. And then I want to see what happens when, we have an invalid parent in this case. Like what does the dashboard show? And we already went through the happy path with the example app. So, oops, I messed that up. So instead, let's apply a rollout. So like I previously said, I do not know much about rollouts. So I actually made a script called create rollout that will just apply Argo rollouts into our cluster. It will install it, and then it will also apply this pod info manifest. So first, I'm going to kick this off, and while that's handling, let's have a look at what we're actually applying into our cluster. You're going to see a bunch of stuff here. It's not all very important to understand what we're doing. The main key here is that we have 3 deployments. This is one. It's a front end. And then we'll have another deployment, which we call a generator. This will send data to our front end. And then the final piece is we'll have a rollout. So this is what replaces our deployment, and this will be a backend. So the generator will send stuff to the front end, which will then send stuff to the backend. And if right now you're thinking, okay, well, you know what you're doing, you have this rollout object, you've worked with Linkerd for a while, what do we do when, we're new contributors and we don't have access to all of these manifests? And the answer is pretty simple. All of the stuff that we mainly use is used throughout our tests as well. So if you go through the integration tests, for example, you'll see that a lot of the applications that we use are publicly hosted on GitHub, such as Emoji Photo, which we also use in the Getting Started guide. And I just test with those most of the times. Whenever I have a change that I want to test, I just apply those manifests, and they're super easy to get. Emoji Photo is like a curl away. So yeah, don't be discouraged by this. Is what I'm trying to say. And yeah, so we apply this rollout. Let's see how it works in practice when we go over to the dashboard. So we're gonna switch our namespace. The new manifest that we applied created a new namespace, and we'll see that we have a generator that sends data to a front end. And we look at the deployments. We'd expect to see 3 deployments, right? Because we have a front end, a generator, and a back end. We only see 2 of them, which is fine so far. But then as we scroll down, we notice there's no table for Argo rollouts, and that's because we naturally don't support it. So the next best thing, the next best thing would be to see all of the stats here in the replica set. It's like we don't have a deployment, fine, but let's at least get something in the replica set here. So that's what our issue will do. After we fix this, we'll see metrics here. Sounds pretty simple so far, I suppose. Well, I hope.
No, you're explaining it all very well. I mean, if I'm keeping up, everyone can keep up. So
cool. So I'm in my VS Code now. I thought I would spare you all from having to see me use Vim. I generally use Cloud Instance to do all of my programming. So I don't program on my Mac, because if I do, it's just going to take off, or if it's going to sound like it's going to take off. And what I did is I opened this API.go file in controller Kate. And this is exactly what Alejandro pointed to in the comment. So I didn't really have to do much. I just hit Command P, controller, package, controller, API. It doesn't show up here, unfortunately, now. So, but yeah, just take my word for it. It works.
I think just because it's opened.
Cool. So, yeah, I hope so, at least. But let's chat a bit through this function. So this get owner kind of name returns a pod's owner, and well, a pod's owner's kind of name. It's pretty self-referential in this case. And what the method does is it accepts a context. We're not bothered with this. We don't actually need to work with it. It then takes in a pod. It has in a retry boolean. We don't need to be bothered with this either. And then it returns 2 strings, the kind and the name, like the comment says. By the way, we're big fans of comments at times. I think it definitely helps give a lot of context to an open source project. But anyway, I won't get sidetracked. What we're doing first is we're getting the pod owner references. So this comes from client Go, the Kubernetes library that most of us use in Go. If we don't have any owner references, then the pod doesn't have a parent. If it's more than one reference, then something's gone wrong. So again, we just return the pod. And then what we want to do is we want to get the pod's parent and look if there's an object that manages that parent, if there's a grandparent for our pod. So there are 2 situations where we have a parent that might have a grandparent. That's a job, as we can see here, and a replica set. So if you're relatively new to Kubernetes, replica sets are native objects that help your pods, help keep the number of your pods stable in a cluster. So it's the thing that, when you say I want 3 replicas of an application running, it's the thing that ensures you have 3 replicas of that pod running. But generally, we don't use replica sets by themselves. We use them with another object, like a deployment that kind of manages everything around it and does everything a bit better, so to speak. But yeah, what we're doing here is we're declaring a parent object, which is a client Go type object. We have an error, and then based on the owner that we have, on the parent that we have, we either have a job, a replica set, or something else, in which case we just return the parent because there's no grandparent to it. Now, what happens here with job, for example, is that we get the parent object, we overwrite this variable, and then at the end, we have another check. If this parent object also has a reference, then return the grandparent. Otherwise, just return the parent. So if this job would be owned by something else, we would return that something else. Otherwise, we would just return the job here. And for the replica set, if you've been faster than me here, what we essentially want to do is we want to not overwrite the parent object here. We want to have something like replica set object. And then over here, we want to check if the replica set object parent is valid. If it is, then overwrite the parent object. Otherwise, just return the parent kind and name. And again, parent refers to the pod's parent here. So I'm just gonna do that. So, okay, so far so good. This will really, like you said, be a two-liner. I'm going to start with an if statement here and say, if we have a Boolean that comes from is valid replica set parent, and this Boolean is false, so it's not valid, then we will return exactly what this default case returns, because we just want to return the pod's parent kind, which in this case is the replica set. Otherwise, we simply replace the parent object with the replica set object. Oops, that's a capital G right there. Yes. Not sure why it's complaining so far. But anyway, over here, we'll obviously need to
It's
create a
because
function.
line 495 RS object is a new variable, but you've only got an equals.
Oh, that's true. Good spot. This is why you need more pair programming in your life. Cool. So the only thing that remains is to create this is valid replica set object, well, replica set parent function. We're going to do this here at the bottom. We know we're going to take in a replica set, and I'm going to cheat here. I already know what the type is because I've been working with this for a while. It's all client Go specific. So if you don't understand it much, don't worry. Neither do I. It's client Go. We all struggle with it. But here we'll basically have this replica set object. And the first thing that we want to do is notice we have a pointer. We want to say if it's nil, then we'll clearly fail. Or if its owners get owner references is not 1, then we'll just want to return false because it's not valid. So what am I doing here? Oh yeah, we said if it's not 1, then we'll return false. The subject is not valid. The next thing that we want to do is check all of the valid kinds that we have. So one way that I would do this, I'm not saying it's the correct way to do this, I'd probably have something like this, valid kinds. And this would be a string array. And in here we'd use some constants that we have to say all of the valid deployment. Valid, let me change this to valid kinds. So we know a deployment is definitely a valid parent. Stateful set is definitely a valid parent. A replication controller may be a valid parent, not sure. A job may be a valid parent, and so on. You'd require a bit of research here, but it wouldn't be too hard to figure out. Just a couple of clicks in the Kubernetes docs page. And finally, what we want to do is say, well, I guess we want to first get the actual owner references. So we'll say owner is get owner references 0. And then we want to check the owner kind. And the owner kind will be owner, that kind. There's a small caveat here. If we look at these, they're all lowercase, and we probably want to have a strings to lower here. Otherwise, the kind won't match. Is everything making sense so far, David?
Yep, all good so far.
And then all that's left is to do a simple for loop. So for kind for parent in valid parents, if our owner kind is equal to the parent, then we'll return true. and at the end we'll return false. And I'm missing a range here. Cool.
Perfect.
And that's it. So now we should be good to get everything going. I don't think I have any errors here. Guess we'll find out soon enough. I lost the connection to the pod here, and that's not sure what's going on. Let's see. So like I previously said, what we normally do is we build the Docker images. So let's make some changes. We're going to build these Docker images. We're going to load these images up in the cluster. We're going to upgrade our control plane because right now we're running a different version. We're going to have a new version, and we're just going to test everything works on. Any questions so far?
No, I'm right here with you. I'm following. I've got to say though, like, you know, you said at the start, this is your first stream and you've came in, you've explained service mesh for a start. You've introduced us to Linkerd, did a code walkthrough, walked us through issue labels, and done a little bit of live coding. Super impressive.
Thank you very much. I'd like to think it's all of the Slack experience that I'm getting. We do a lot of support for our users. So that's one of the cool things about Linkerd. You know, obviously I'm biased. There are a lot of cool things about Linkerd, but we're very community oriented. We like to help each other out a lot. And it's not just me here or the maintainers. It's community members helping each other out as well. So it's really, really cool. And on that topic, I have a bit of a well-kept secret. It's not really a secret, but I just realized a lot of people don't do it. We have a Slack channel, a Slack workspace that you can join, but we are also running a Discord server. And usually the dev team, the maintainer team, keeps things transparent on Discord. We have a dev channel where we talk about issues, we talk about potential fixes. You know, when I have silly questions, that's where I go and ask them. So you can enter that channel and you can sort of spy on us or ask your own questions. It's a transparent forum for development work on Linkerd. So if you can, definitely check it out. I think it would be helpful.
All right.
Yeah, so these builds don't usually take a long time. I mean, I'm saying that, but it's still building. Maybe 5 minutes.
Looks like Jason tried to give you some claps in the chat, and unfortunately our moderation bot caught it as spam. Sorry, Jason. And import human saying you made that look so simple, smiley faces. Jason managed to get one clap in there. There we go. I'll try and see if we can tweak that Nightbot moderation for next time. But everyone's thoroughly impressed with that. That was a solid performance. So right now we're just waiting on the container images to build, which I'm assuming will be thrown into our cluster, and then you're going to issue a rollout?
Exactly. The rollout is already in there. So I'm going to basically just restart everything so it gets injected all over again. That'll pick up our new changes and it will hopefully work. I've taken a bit of time explaining this, so let's see if this will drag on building, because otherwise we can also talk a bit about the review process, which is my favorite thing about Linkerd.
Yeah, I just want to check, you know, we're approaching where we said we would finish, but I'm happy to go a little bit over if you've not got a hard stop. Also, I'm curious, I see on your terminal it says Mate AMS1C3. Is that a Equinix Metal device?
Yes, it is. Yes, it is.
That's the best way to write code. I do the same. So why use my laptop, which the fans go wild, when I can use a beefy cloud instance? And those C3s, if I remember right, have got like 64 gig of RAM and 16 cores. So
honestly, it's a dream. So coming off working on a MacBook Air as a student, 2017 edition, where, you know, I always had to just run one browser tab, otherwise everything would just crash.
Yep.
To having my own cloud instance, it makes everything such a breeze. I recommend it. If you have the opportunity to toy around with it, definitely give it a try. Cool. But what I'm going to do now, what I'm going to do now is you'll notice that our build completed. And like I said, this will put in a git tag, git hash or whatever as a version. But this is not in our cluster right now. And since we don't want to push it into a repository, we're just going to load it directly into K3D. So again, we have a script. It's called image load. This is also documented in test or build.md, I believe. I'm not sure, honestly. It has been a long time since I looked at those docs, but it's documented somewhere. So if you don't remember it, don't worry. You're definitely going to come across it. This didn't take too long. So now we have the new images in, and the Docker image, actually the Docker build script, sorry, also built a Linkerd binary, which we have a script for to reach, so we don't have to go to the actual build output directory and everything. So basically here, it's easier to show. If you do Linkerd version, you'll see that the binary runs the new version that we've just built, but the server still runs the old version. So naturally, the next step is to upgrade the control plane. So this is done through our upgrade command. And then there's also this prune kind of argument that we use for kubectl. So this is kubectl. I'm sorry, I'm using aliases. Honestly, I'm not sure what prune does. I never really understood it, but I always use it. So, at this point, it's one of these things that I don't question. Yeah, so let's see how our control plane is doing. It's already running. Sick. So the next thing is the seal of pods in pod info.
So just because you mentioned it, and I had no idea what prune did either, so I have Googled it, and it's actually interesting. So it actually takes the labels from the objects in the manifest and deletes anything on the cluster that has those labels that's not in the manifest anymore. So there we go.
Okay. I knew it had something to do with pruning, but yeah, I was thinking of pruning, like when you prune a tree or a plant, you take the old leaves out. So I was like, yeah, it has to clean something up, but
Yeah,
beats me what it is.
I had never used that before, so yeah, today I learned.
Now what I'm going to do is delete all of the pods in pod info. So this is the rollout that we had, and I'm deleting them because we want everything to be injected again, right? So we've made changes to this API function. This API function is going to be used by the injector. And these pods were already injected. So what we want is we want to force them to go back through the injection cycle. And hopefully when they come back up, we'll see metrics for replica sets. So I think actually we don't have to wait on that to finish. Because if we do this, we already have our instances running. So fingers crossed. Oh, we need to also open the dashboard. Waiting for this extension. Let's see what's happening there. So again, this is an alias. Okay. So this should be running. So I have no idea why that didn't work. Oh my god. I'm not nailing the commands here, but yeah, there we go. So right back into the dashboard. Wait for this to refresh. See, now I'm getting impatient. It's okay. Let's just go directly to the dashboard. Okay, what's happening?
Oh, I think your port forward crash.
Yeah, that might be it. So let me quickly deal with this. Bunch of command line wizardry going on. Oh, come on. You know what? If this doesn't work, there's another thing we can do. So everything that you see in the dashboard, and this is actually a good point, everything you see in the dashboard is also available through the CLI. So if we do this help, we'll see that we have a couple of commands. The one that we're interested in right now is the stat resource. This displays traffic stats. And again, that's kind of what we're looking for. So if we do bin linkerd is stat replica sets in the pod info namespace,
Yeah, nice.
zoom in. we're going to see that just as before, we have three replica sets. We have front-end generator and pod info. Pod info is now getting metrics because its parent is not valid. The other two are not getting any metrics. So we can also verify they're getting metrics through their deployment by doing deploy pod info. And we'll see that they're getting metrics through
Awesome.
their deployments. So there you go. That's fixed.
We don't
Now,
need no GUI. Well done.
yeah, exactly. Gotta, think outside the box. I was actually talking to a colleague about it. I don't use the dashboard very often. It's always CLI. There's one last step that I want to do. Two last steps. First, I'm going to make sure everything tests out well. And while that takes its time, I'm going to commit our changes. So first we add the file, and then we say git commit -s. The s here is important because we want our commit to be signed off. We have a DCO check, which basically checks that you're okay with making this change. And you're making it out of free will and everything else. Don't take legal advice from me, please. But basically, this will just introduce this signed off thing here.
Can I
I
ask a
see that one of
question?
the tests failed. Yeah, sure, go ahead.
I think it's quite common, especially in Go projects, that when you are developing locally, like the Go mod or the Go sum would change. Like, should those be committed along with that, or should we omit those?
So I think it comes down to preference. I personally do not think you should commit it unless you have explicitly changed the dependency. If your PR is about changing a dependency where you're like, okay, I'm going to increment something or we need a new version because what we're trying to do is not supported, then yes, definitely commit it. Otherwise, I think it's best to keep those log files and mod files as they are because they kind of guarantee integrity when it comes to dependencies. So you generally want that to stay the same unless you make an explicit effort to edit any of the dependencies. This just ensures basically whoever runs it next won't run into issues. And
Makes
going back
sense.
to JVM, some of the Java projects I had to run were all red because of dependencies. So yeah, have a strong preference there. So I think we failed here. We might be missing a type. For that we didn't really account for, and I can't remember what the type would be. So we'd probably have to look. This is a bit besides the point. So first off, let me show you what I would do when I do have a test failure. First, I would commit the work that I've done so far. So normally the way we like it in Linkerd is to have a subject. You start your commit with a subject. The subject starts with a verb, present tense, and it's about kind of what you have done rather than the result of what you have done. So I'm just going to say add parent object validation for replica sets. Then we would usually add in what the problem is. So I'd say, well, the problem is for parent objects that are not supported in Linkerd, we cannot get any metrics. For example, using a rollout will not report any metrics higher than a pod level. Obviously, you usually have a bit more time to finesse through these commit messages. Then I think the next thing that we usually do is say what the solution is. The fix, add validation for replica set owners. If it's a valid parent, use parent find the name. Otherwise, use replica set. And then how we tested it. Tested using CLI UI. And we just saved that. And yeah, that's pretty much it. Now, with this thing, I think I'm missing something obvious here, but I cannot remember what it was. So I'm going to show you exactly what I would do when this happens. First, I would go to my get owner kind, sorry, wrong one. I would go to my get owner kind function and see exactly where it's being used. So let me just search for it, get owner. Is it get owner name and kind or something like that? I already forgot. Yeah, there you go. I would go to references and I try to see the one that applies to what we're trying to do right now. So we talked about the proxy injector and how this is used in the proxy injector. So this is probably the file that we would like to snoop in. And over here, I'd expect somewhere to see some types for an object. There we go. We have replica sets, replication controller, daemon sets, stateful sets, and what do we have in get owner and kind when we validate? Stateful set, replication controller, job. So which one are we missing? Um, jobs? No, I think, oh, daemon
Cron
sets.
jobs, daemon sets.
Yeah, I think it might be daemon sets. Uh, yeah, it's a daemon set, I think. Daemon set. And yeah, let's see if this fixer rests. I'm hopeful it did, because otherwise I'm going to run out of ideas. But while that completes, there are also two other functions that, well, two other scripts that I recommend you run before you actually push your changes, and that's bin lint. This will tell you if you have lint failures when it comes to Go. So lint failures are generally kind of like stylistic choices that you make. For example, it's not necessarily stylistic, but the example that I have in mind is you declare a constant, and that constant is not used anywhere. You would not want that in. So um, expected it to be deployment, and it's a replica set. Uh, okay, and the next one, right before I dive right back into changes, is bin format, which will check for any formatting failures. I keep messing this like transition, but here we have deployment, and it would have expected it to be a deployment. So let's see exactly what's happening. Might be a bit beyond the scope of the stream.
Yeah, we can always move towards the review process, like, and you can fix this in your own time. I don't think we. I mean, if you want to debug it, of course, feel free, but no pressure.
Let's quickly go to. I want to see if we can quickly nail this. So if we have the parent name and the parent kind, oh, is this why? No, because we don't want the name to be replaced. Yeah, I'm not sure exactly what's happening
What was
here.
the
I
error
think
message on your test? Sorry, I don't think I actually saw it.
I think it's expecting a deployment, and it got a replica set over here. So this wouldn't necessarily happen. Like I wouldn't expect this to happen. So that's why I'm a bit.
Let me see your range loop. Maybe there's just something silly in that end. I feel like I'm going to try and see if we can work this out.
All right, help me out with the debugging effort. So we get the owner reference, we get the owner kind, and if the owner kind is the same as the parent, then we return true. Otherwise, we return false. And this is a deployment, stateful set, replication controller job, and daemon set. Yeah.
All
So
right. Yeah, I'm not sure. I mean, your code looks all right on my side. So why don't we just go through the pull request process, and we can laugh at whatever the silly thing is later.
let's see. So assuming all of our tests are passing, we now have our commit there. I should probably branch out. I should have done that before. The maintainer team usually prefixes the branches with their name. I'm going to say fix replica set. Not very intuitive, but yeah, whatever. We can see again, our branch has the latest commit in the log. Normally, you would push this to your fork. I will use my privilege to push it directly to the repository. And then we're just going to go on the website, and here we are. This will open a pull request. If you are working through a fork, you'll typically still get the same kind of thing. except that instead of merging it into your fork, you want to merge it into the, main repository base. So yeah, this is kind of it. I'm a big fan of writing very, very detailed pull request messages. This time I'm just going to let it take whatever's kind of populated in the commit message, and you'll see that this is the actual issue that we have, the solution and the validation. I'm going to create this, and then I'm just going to wait for somebody to tell me my tests are failing. The tests are going to run again here. So if for some reason you forgot to run the integration tests like I just did, or if you forgot to run the unit tests, this will also run in the actual Git repository. So to give you a bit of a taste about reviews in Linkerd, I'm going to go to the only other pull request I have open. And you'll notice that I have a few comments over here.
101 comments. Wow.
It's 101 comments. Like I said, we like to be really thorough. And this, to be honest, in my defense, this was also a proof of concept. So it was a lot of really trying things out at first, and a lot of updates on my side. Like half of these comments are mine, I think. But yeah, this is how I normally write my pull request messages. I simply use a what, how, and why. What's happening, why are we doing this change, how are we doing this change, and then how did I test it. So in this case, we're trying to change the API to allow for stateful sets over multi-cluster. It's a bit beyond the scope, but just to show you, I typically write updates after every single commit that I push. You'll also notice that I do not squash my commits after I've opened the pull request. And this is something that I personally appreciate as a reviewer. If I have a bunch of commits before I open the pull request, it's okay to squash them and have just one commit because it makes it easier to visualize. But once you open the pull request, it's very helpful for the person that reviews to see the entire Git history. If you have 10 other commits that you push onto this branch and it goes into the pull request, it's very helpful for us to see how you went from point A to point B and everything that happened in between. Otherwise, sometimes you can miss out on context. So it's not a strong preference, but for me, it is a preference. Either way, doesn't matter how you do it. It's not wrong. It's just if you can not squash them, that would be perfect. And then yeah, it's basically a lot of back and forths about how everything is supposed to work. Ideas, we bounce ideas off of each other. If something doesn't work, you kind of get your attention drawn to it. There are also code comments. I think at this point we were a bit too early for code comments, but the more we kind of look through here, the more we'll find, like here, for example. Can you point to where we hit a nil pointer here? And I actually couldn't. So these are all things that you can kind of address. And the reason why I wanted to show this pull request in particular, I could have shown any other one that doesn't have 100 comments, is that, again, if you're a new contributor, I think it's very helpful to contribute to a project like Linkerd because it really gives you a lot of help from people who have been around the industry for such a long time and who have seen so many things as far as engineering goes. And not just those kind of people. Like you get people from different backgrounds reviewing your code, giving you advice, and pointing things out that might happen in your changes. So it's all very useful, especially when you're starting out. So whenever you get a question on your pull request, don't take it the wrong way. It's usually the reviewer wanting to help you out and wanting to make sure that we have the best work that we can have. So yeah,
Awesome.
that's kind of it.
All right. Thank you for guiding us through all of that. There was a lot.
Yeah, I know it's a bit to take in, but yeah, hopefully everyone could follow. If you have any questions, you can find me on the Discord and Slack channels. So always feel free to reach out to me. I'll make time to answer them, especially if you lead with I'm a new contributor. If you lead with that, I'll make extra time just for you. So you know.
Yeah, this was perfect. Like, this is just a canonical reference now for anyone who wants to come along and understand Linkerd and start to contribute patches to it. I think you just covered so many important parts here about how to work with Linkerd, how to modify the code, the test, and then, you know, Linkerd is one of those projects that you do need to kind of run it in a Kubernetes environment, and just seeing how those build scripts are all there. And the documentation looked fantastic throughout as well. I think it's just great that you managed to share your story as well, of getting started, contributing, and now working at that point, which is hopefully gives a lot of other people that were in your position something to look forward to themselves and get involved. Like, contributing to open source can lead to wonderful things. And the live coding, that was that was very brave. People struggle with live coding, and you handled that effortlessly. So, you know, great job.
Well, you know, we're still failing a test, so you know, be sure to check in an hour from now when I start getting grilled from.
Yeah, but it's going to be something really, really silly. Like, when you've got the camera in front of you, of course, it's easy to skip the simple things. I bet it's a return false, return true weird thing or something, but you get it fixed. It's a cool. It was really nice just to see the whole entire process from start to finish. So, thank you very much for joining me today and guiding us through that. It was an absolute pleasure.
Thank you for inviting me. Thank you for having me. You know, thank you everyone for your attention. And yeah, hopefully this will get you excited to contribute.
All right. Well, I know we went a little bit over, but thank you for hanging out. I hope you have a great day, and I will speak to you soon. To everyone that watched, thanks again.
Thank you, everyone, and have a great weekend.
Bye.
Massive on the code.